So in this video, we're going to talk about complex numbers a little bit. And complex numbers kind of arise from this issue. We know how to do the square root of 4. The square root of 4 just simplifies to the positive real number 2. But and it does because 2 times 2 is 4. 2 is the non-negative number such that when you multiply it by itself, it yields a 4. So if we try to simplify something like the square root of negative 4, the problem is that the answer can't be 2 because 2 times 2 is 4. And in fact, the answer can't be negative 2 because negative 2 times negative 2 is 4. Neither of these two products yield a negative 4. So complex numbers, or the imaginary or complex unit, I prefer to call it, in textbooks it's called the imaginary unit. I think it's an unfortunate name. I prefer to call it the complex unit myself. The issue is that when we get the square root of a negative, there isn't a real number such that when we square it or multiply it by itself, we get a negative 4. So what we do is we use a result from previous courses where if we have the square root of a times b, and a and b are not both negative numbers, we know that that the square root of a times b can be rewritten as the square root of a times the square root of b. So this is a result from probably Algebra 1, maybe even prior to Algebra 1. So what we do is we rewrite the negative 4 as negative 1 times 4, and then we use this property because only one of a or b are negative. We use this property to rewrite it as the square root of negative 1 times the square root of 4. And we know how to simplify the square root of 4, so we get square root of 1 times the square root of 4 is 2. And then what we're going to do is give this guy here a name. We're going to say, let's call the square root of negative 1. I know it's not 1 because 1 times 1 is positive 1. And I know it can't be negative 1 because negative 1 times negative 1 is positive 1. So let's give this a name. Let's call this I. And this is the complex unit. So the complex unit is simply the number whose square is negative 1. So we give this guy a name, we call him I, and we get I times 2, and then usually it's customary to write it in the form 2 times I, using the fact that order of multiplication doesn't matter. So we usually put the real part kind of in a coefficient position on it. So long story short, I've kind of summarized the important pieces. The square root of negative 1 gets a name. We call it I. And this is going to mean if we're doing I times I, we're really getting the square root of negative 1 times the square root of negative 1, which is the same as the square root of negative 1 squared, which just simplifies to I. So those are the two big pieces. Square root of negative 1, we give it a name, I, and I times I is negative 1 because the answer to a radical is the number such that when you square it, you get the number that's on the inside. So I times I is the negative 1. So using this idea, we can define what are called complex numbers. It's common to give them the letter name z. And a complex number is any number that has the form a plus bi, where a and b are any real number that you want. So any real number from the real number line. And I is the solution of the equation x squared equals negative 1. Or in other words, I times I is negative 1. So complex numbers, anything that has the form a plus bi. So for example, 7 is a complex number because 7 can be written as 7 plus 0 times I. 3i is a complex number because it can be written as 0 plus 3i. So it can be written in the form real number plus real number times I. So anything that looks like this is a complex number. I got the vacuum going in the background.